So we have discussed a lot of things related to the function. So let's now at this point of time move further and discuss some more things in the function. Okay. So let us discuss this thing. So we discussed like methods to check one function, and earlier we checked the algebraic method. Okay, so we'll check here the algebraic graphical method. Because obviously there are a lot of more different ways to check the if a function is one or not. So let's explore something. So, like in this part, I'm going to discuss the different method, which is called the calculus method. Okay, so calculus method I'm going to discuss, and like this calculus method will check for different derivatives. So I think you are already aware about the differentiation and basic part of the differentiation, like how to do a differentiation. And for that part, let's discuss how this particular thing is check if the particular function is one or not. So like if you just check this particular graph of the one function, you can see that a particular curve is either increasing or either decreasing. So if you just see the curve of y is equal to fx, you can see that this particular curve is increasing. Okay. If you see the line of y is equal to x, you can see that this particular curve is also increasing. And if you just also see this particular curve of y is equal to log x, you can see that this particular thing is also increasing. So means that any particular graph which is a one-on function, it will be either strictly increasing or it will be either strictly decreasing. So this fact we will use. So like in calculus, when you will read about the calculus, there is something called strictly increasing and strictly decreasing. And if you have a function fx, and if you find the particular derivative of the particular function, so like a particular derivative of function is represented by df by dx. Okay, and it will be represented by f dash x. It is greater than f dash x. So if f dash x is greater than 0, then it is treated as obviously the increasing function. And if f dash x is less than 0, then this particular function is termed as a decreasing function. Okay, so if a particular function is increasing or decreasing, you find f dash x, and if f dash x is greater than 0 for all x belong to the domain of a. What is the domain of x? So obviously if a function f is defined from a to b, then A is the domain of the particular function. So we'll discuss the domain and range in some part, but obviously this is the basic fact that you need to do. If a function is 1, then it will be either strictly increasing, or it will be either strictly decreasing. Okay, so this fact you have to remember to check if the particular function is 1 or not. So let's see some particular questions and how we can solve this particular question. So the question is, there is a function f defined from r to r and is given by x cube plus a plus 2 ka whole is x square plus 3x plus 5. It is saying that it is a one function. It is saying that it is a one function. Then a belongs to the interval. Then a will belongs to which interval? Okay, so this particular thing we have to solve. So we can easily solve this particular question using the particular formula that I discussed with you now, this particular differentiation formula. So we know that this particular function is the one function. Then in that particular case, it is sure that f dash x should be greater than 0 or f dash x should be less than 0. Okay. So r to r means real to real, this function is defined. So your fx is defined as x cube plus a plus 2 ka x square plus 3ax plus 5. So if you do f dash x here, f dash x you will get 3x square plus 2a plus 2x plus 3a. Okay, so this particular thing you will get. Now this should be greater than 0, because we know that if the particular function is increasing or decreasing, f dash x should be either greater than 0 or less than 0. So do f dash x greater than 0. Okay. So if you do f dash x greater than 0, you will get something, and if you do f dash x greater than 0, you will get something. So what you will get, just let's discuss that particular point. Okay. So if it does give you f dash x greater than 0, then in that particular part, this thing will imply that 3x square plus 2x means this particular difference is greater than 0 for all x. This imply that 4 into a plus 2x square. This means this just will solve this particular part. So if you solve it, you get 3x square. Okay, plus 2a plus 4x plus 3a. Okay, so it means that it will be 3x square plus 4x plus 7a. Okay, so like what we will do here, we will solve this particular questions using the means the what you can say this, if you just know about the quadratic equation, you know that if particular, obviously we are actually here utilizing the properties of quadratic equation. So if you have quadratic equation x square plus bx plus c, then this particular thing is greater than 0 for all x. This particular thing implied that discriminant is greater than 0. What is the discriminant? Discriminant is b square minus 4ac should be less than 0. So this is a particular property of quadratic equation. If the quadratic equation is greater than 0, means obviously this is a quadratic equation and it is saying it is greater than 0. So this thing means that the discriminant should be less than 0 and discriminant b square minus 4ac. So if you do b square minus 4ac, obviously you can calculate it from here, which is 4 a plus 2 ka whole square and minus 4 into a into c. What is minus 4? Minus 4 is minus 4. A is the 3 and C is the 3A, which is good. 4 into 3 is 12 means 36A. So this should be less than 0. Obviously, you expand it and solve it, you will get this particular thing. And if you solve it, it will be A minus 1, A minus 4 less than 0. And this will give you A lies between 1 to 4. Like there, we are actually utilizing a lot of concept related to the solving probability and obviously the inequality. So if you're not aware about the inequality, I will just advise you to just go back and revise some of the concept to the inequality. But also this function, this particular concept is not so hard because it just utilize the fact that f dash x greater than 0 or f dash x less than 0. Obviously, if f dash x greater than 0, then this particular thing is going to be uh, this thing. Okay, so this fact you have to utilize it and so to solve this particular question. Okay, now here the thing is that okay, now the here the thing is that you have to solve this particular question. So I don't know whether you know about how to solve the particular inequality or not, but obviously in these questions utilize the fact of quadratic equation, then the inequality, and using these two concepts you can easily solve this question. But the fact is that either f dash x is greater than 0 or f dash x less than 0. Obviously, if you solve this particular two questions, you get that thing. Okay. So now let's discuss the some other thing. So like we discussed, actually discussed number of functions from a to b, number of so at this point of time, let's now discuss number of injective functions, number of one-to-one functions from a to b. So just let's study this part means smoothly, and we can understand everything. So if a and b are finite set having m and l elements, so it is saying that a is the set, obviously function defined from a to b. A has m element and b has n element. Okay, so now the thing is that m is less than equal to n. So obviously the number of elements in b is greater than equal to number of elements in a. Okay, then to define a one-one function from a to b, we have to create m elements in a to n elements in b. Obviously, like this is the thing that is the proof. Actually, I want to show that. Let's say this is the a part. Okay, and this is the b set here. Let's say it has n element. Okay, it has n element and this has m element. Okay, obviously it is given that n is greater than equal to n. So to create the one function, it means that we have to relate m elements in a to n distinct element. Like if there are, let's say there are m is greater than equal to n, means in the number of elements in b is less than equal to m, then this function is not going to be one at any point of time, because obviously number of elements, just if m is greater than n, then there will be some element in m, there will be some element in a that is going to relate with two elements of b. Okay, so like this is going to the same thing and this is also going to the same thing. So two elements of a is going to relate to the same element of b. So this should not be there. That's why number of element, the restrictions on number of element is that m should be less than equal to n. If m is greater than n, obviously this is not going to be one function. So what we need to do, we need to relate each and every point to the distinct point of B, each and every point to the distinct point of B, any distinct point. So obviously, if n is greater than greater than equal to m, then obviously we are going to find a unique point for each point in A, for each point in A. So like total number of points are n. So we have to find m number of such combinations, and obviously we have to multiply by m factorial because we can arrange those m points into any manner. So let's say there are 3 cm. NCM means out of n total point in B. We can obviously relate to choose any point in M, and we can obviously relate those M points in A to any point in M. Obviously we can arrange those things in M factorial way. How these things is happening? Obviously, I told you earlier also. Let's say these are A, B, C, three elements in A. Okay, and this is a B. Let's say there are four elements. Okay, four elements. One, two, three, four, five. Okay, so obviously let's say A goes to 1, B goes to 2, and C goes to 3. But obviously for these three elements, you can also find some other permutation also. Or you can say that maybe A goes to 1, but let's say we can also arrange it as A goes to 2, B goes to 1, and C goes to 3. So this is the another combinations out of these three elements chosen and these three elements chosen. So obviously total number of one function is going to be NC m into m factorial if m is less than equal to n. Obviously, this condition is, I explained why this condition is true. And if m is greater than n, then we are not going to have any one-on function. This any function is not going to be one. So this fact you have to keep in mind. What how to find the number of one-on function from given a and b. Okay, so now at this point of time, let's discuss the one-to function. Like what is a onto function? Okay, so one-on function I already discussed. Number of one-on function I already discussed. So let's now discuss the onto function. So the onto function, the a function f from a to b is said to be an onto function or a surjection. So one-on is called injection and one-to is called surjection. If every element of b is the f image of some element of A. So you can see that what this particular definition means. It means that every element of B is an f image of A. Means if you choose any element of B, it is going to be related with some element of A. If you are going to choose any element of B, it's going to be related with some element of A. You can see that this one here is related with some element of A. This two is also related to some element of A, but this three is also related to some element of A. But in this part, you can see that this is not onto function. This second part, why this is not onto function? Because if you talk about the four, so 4 is not actually related with any element of A. So it is all that is what it is saying. If every element of A is the F image of some element of A. So every element of B, if you choose any element of B, it is going to be related with some element of A. Okay, if it's not related to some element of A, in that case, that is not an onto function. Simple definition, simple funda. Okay. So it's also being explained in some other way. If f a is equal to fb, or range of f is the codomain of f. So like there is something called codomain. Okay, and there is something called range. Okay, so codomain means all the points of a particular f. So let's say f is defined from A to B. Okay. Then all the points, let's say we put f A and then it gives some element B, and B belong to capital B. All for all the B capital belong for all A. This belong to capital B. Okay. So what I want to say is that the codomain means whatever the values you are taking from, you are getting from f. Obviously, you are putting A and getting some values of f. That particular thing is called codomain. So what is the difference between codomain and range? Okay, actually codomain is the big smaller part. Let's say ki, this is the I don't know how to explain this particular thing. Obviously, I will explain this codomain and range later, but just for now, just for the sake of understanding, just think that ki is one onto function if each and every element of B should have an image in A. Okay, so if f and b is onto function, okay, then for each b belong to a, there exists a such that f is equal to b. So I explained this part. Whenever you choose a particular element in this particular part, okay, so this you are going to get a element in A. Okay, for each element in B, you are going to get element in A. Okay, okay. This particular thing is there. Obviously, for any particular part this is not there, then this is not the one onto function. If f and f is not an onto function, then this is called an into function. Okay, so obviously one and many one. So something was called one, but if it's not one, it is many one. Obviously, if something is not onto function, it is called an into function. Okay, so these are the different nomenclature of the function you need to keep in mind. But obviously, for the onto function, you have to find a point in B. If that point is related to A, that is onto function. But if you find any point in B that is not related to A, so for every point in B, it should be true. But if for any point in B, if it is not true, then particular thing is not be called as onto function. Okay. So how to check an onto function? Obviously, the way to check an onto function is simple, but I don't know whether this particular thing is going to come in the exam or not. But I thought I should include this particular part. So to check the surjectivity or onto function, what you need to do, you need to find the what you can say, you need to find the range of a function. Okay, so choose an arbitrary element y in B. So obviously f is defined from A to B. So choose an element, let's say y belong to B, we choose an element y. Now what we need to do, we need to put fx is equal to fy. So we assume that for any element, obviously the function is defined from A to B, and for each element in B there should be some element in A. So if we we choose a point y in B, so there should be some element in X that correspond to y. And then what you need to do, you need to solve the equation fx is equal to fy for x and obtain x in terms of y. So if you just solve this particular equation, you will get x is equal to some function of y. Okay, not f, some function of y. So obviously it means that okay, this particular thing is going to be onto function. Now if for all value of y belong to b, the values of x obtained from the x is equal to gy are in A, then f is onto function. Obviously, this particular thing will give you something in terms of y. And I think if you're going to solve this particular part, you are going to get uh, some interval or something like that, and then you can means I think this particular thing should be clear with example mode. So just let's do this thing with example. Okay. So the thing is that a function f from R to R is defined by fx is equal to 2 to the power x plus 2 to the power mod x. Okay. And you have to find whether this function is on one, on two, or what this particular function is. So obviously 2 to the power x is this function defined from R to R. The domain is R and range is also R. So for 1 1, how do you check the 1 1 function? For 1 1, we actually choose if x not equal to y, then this imply fx not equal to fy. So this is the 1 1 function. So obviously, if you choose 2 to the power x, even though 2 to the power x is not equal to 2 to the power, obviously x not equal to y imply 2 to the power x equal to not equal to 2 to the power y. This imply 2 to the power x plus 2 to the power mod x not equal to 2 to the power y plus 2 to the power mod y. How this particular thing is true? Obviously, if you choose any number, let's say x not equal to y, 1 and 2 you choose. Obviously, 2 to the power 1 is not equal to 2 to the power 2. So this particular thing is obviously true. Now, in the both the inequalities, I do add something. So let's say you are adding 2 to the power x and 2 to the power y. How you can add something? Obviously, if x and y are not equal, then 2 to the power mod x plus 2 to the power mod y are also not equal. Okay, so this thing is also true. So you can add those two things, and obviously you consider this particular thing implied that fx not equal to fy. So this is a one-one function. But how to choose the onto function? Obviously, for onto function, you have to check if whatever the value we choose in the range, obviously the this part, actually you are going to get the this part you are going to get something. Okay, so how to check this particular thing? Let's now check this particular thing. So it means that fx is equal to 2 to the power x plus 2 to the power mod x is greater than 0. This thing is true. 2 to the power x plus 2 to the power mod x is greater than 0. So it means that whatever the value of x you put, whatever the value of x put, you are going to get only the positive real number. Okay, you are going to get the positive real number. Positive means, okay, r is actually the real number starting from g in minus infinity to infinity. Okay, but the thing is that this particular thing, any value put, let's say you put -1 or x you put -2, obviously we are going to get one the positive value. So it means that you are going to get the only the r plus is one the positive value, negative part you are not going to get. So obviously it is defined from r to r, but there are some particular values in the range, obviously, which you cannot get when you just calculate from the domain. So for each and every part in the r, actually not you don't get an image in f. Obviously, like this is the f defined from r to r. Okay, so there are some points in r which actually does not relate to any point in this particular domain. And how what those points are? Those are the negative points. So obviously, for any negative points, you don't get any such things here. Okay, so only you get whatever your values put, you get only the positive thing, but negative, for negative part you don't get any value here. Okay, means this part is not going to be negative. This 2 to the power x or 2 to the power mod x is not going to be negative anytime. Obviously, this is not a onto function, because you have find some points in the r, this particular thing, where you don't get corresponding point in the corresponding point here. Okay, that's why this is just a onto function. Okay, so these things you have to keep in mind. I don't know whether this particular thing is asked or not, but obviously many on one or on two, this way you have to check. For x not equal to y, you have to proceed this way. And for obviously for this particular part, you have to check if you find any such point here that actually does not relate to any point in the this domain. Okay, so obviously there are ways to find number of onto function also. So how to find a number of onto function? So if A and B are two set having m and n elements, there are two set A and B having m and n element respectively, such that n is less than equal to m. Obviously there are some elements in B also, and n is less than equal to m. Then the number of onto function from A to B is defined as this particular formula. Obviously, it means this particular formula as a proof, like how this particular things come. But obviously, at this point in time, if you just don't know the proof, also it will work, because just need to see how this particular formula is working. Okay, so let me just show you some examples of this particular formula. So total number of onto function from the set A to set B. So this is set A, which has 4 elements, and this is set B, which has 3 elements. Okay, so A and B are two set consisting of m and n elements. Obviously, n is means n should be less than equal to m. This is true. Then the number of onto function from A to B is obviously this particular thing, NCR minus 1 to the power n minus r to the power n. So this particular thing is there. Obviously, what is n here? N is here is equal to 4, because sorry, n is equal to 3 here, and m is equal to 4. Okay, so you have to write it here, sigma r is from 1 to n. Okay, n is the 3, and minus 1 to the power 3 minus r. What is n minus r? And ncr means 3cr r to the power m 4. Just you need to apply the formula. Obviously, you can expand this particular thing by putting r is equal to 1. If you put, you get minus 1 to the power 3 minus 1, which is 2. So 3c1 3c1 1 to the power 4, then 3c2 2 to the power 4 for r is equal to 2, then plus 3c3 3 to the power 4, and solve all this particular thing to get the number of onto function. Okay, so nothing different, you just need to apply the formula and solve this particular part by putting the value of r is equal to 1 2 3 up to the n part. Okay, so this is the way you find number of onto function if you are able to find from a to b. Okay, so let's say here is a questions from I think paper also. Let's discuss how we can do this. So obviously onto is also called surjective. Okay, onto is also called surjective. So let x is equal to x1, x2, xn. So a particular x is there. There are n element in that particular thing. X1, x2, and there are xn. Okay, and let there is a y. Okay, y is two element only, y1 and y2. Okay, so obviously it has the I think the first set it has means the second set, the b that you talked about, it should have n element and n should be less than equal to m. So obviously n here is the 2 and m here is n. Okay, m here is n. So number of surjective function from x to y is equal to. Okay, like this thing you can also find using formula, but I think this thing you can also find using the intuition. So obviously surjective function means whatever the value you choose in this particular uh, y, you are going to get a particular mapping from in particular x. Okay, so the thing is that here you have to means for this particular element means that the x1 is going to be related to either x1 or x2. So for x1 is going to be related to two elements of y. Okay, so actually there is a two chance of y, means obviously for any x1 either it can relate to y1 or y2. Obviously x2 is also going to relate to either x1 or y1 or y2. So for all the xn, either they are going to relate to y1 or y2. So let's say we actually find all those combinations of such possibility. So obviously let's say we are talking about some particular time point t1. Okay, it may happen that x1 is related to y1, x2 is related to y1, x3 related to y1, some is related to y2, some y2, then y1, then some y2. This particular thing is there. So whenever you are going to get choose such a y1, you are going to get that such those particular element y1 is related to some element of x. Okay, so it means that the total number of possibilities 2 to the power n. Okay, but there are two different possibilities that we are not considering. It may happen that let's say all the elements of x are related to the same element of y, that is y1, or it may happen that all the elements of x are related to the same element of y, which is y2. So there are two conditions in which either of the elements of the y are not considering. Okay, so it may happen that like let's say we're talking about x1 have two choice either y1 or y2, x2 have two choice either y2. Let's say every element follow the same choice, means either they are related to y1, then we are not considering y2. If both are considered to y1, then we are not considering y1. So there are two possible cases that we need to ignore, and in all the particular cases all the elements of y are actually associated with some element of x. That is why total number of surjective function is 2 to the power n minus 2. So this is the based on intuition only. You don't need to apply formula because there are the uh, limited number of the what you can say element. You can also solve this particular thing here also. If you have four elements here, okay, and you have three elements here, so obviously this particular element is going to have three choice, this element is going to have three choice, this element is going to have three choice, this element is going to have three choice. Okay, so total choices will be 3 to the power 4. But obviously it may happen that some elements are actually related to two elements only, actually related to two elements only. So you have to eliminate those two element case, then those one element case, and then finally you are going to get those uh, uh, real part. Okay, so that is what actually being represented by this formula also. So I don't know, I'm not explaining the proof of the formula, but if you go to the proof of formula, this is actually what it do, what we have done here. Okay, so at this point of time, let's discuss the bijection function. So obviously, if a function is 1, 1 and on 2, means if function is both 1, 1 and 2, then that particular function will be called as a bijection function. So if A and B are the finite set and f is defined from A to B is a bijection, then A and B must have the same number of elements. So it is a theorem, or you can say that it's just a basic understanding that if a function defined from A to B, okay, A to B, then a number of elements in A should be equal to number of elements in B. That's only the case when the function is going to be bijection function. So if a bijection function is given, you have to assume that the particular function is bijection. It means that A and B have the same element. Okay. And the thing is that if a set A has n element, and then the number of bijections from set A to B is the total number of arrangement of n distinct item taken all the time, which is n factorial. So obviously, like total number of function means, let's say this particular thing is talking about the bijection function. So a can be related to 1, a can be related to 2, a can be related to 3, a can be related to 4. So obviously, there are total 4 factorial ways by which total number of arrangements can be done. At the next point, it may happen that a is related to 2, b is related to 3, c is related to 1, and d is related to what you can say 4. Obviously, this arrangement is also possible. So total number of possible arrangement are 4 factorial. So n factorial is the total number of element, total number of bijection function from set A to B. Obviously, n is the size of the set A because both the set has the same number of element. Okay, so not a bijection function. So you consider this particular function not a bijection because obviously this function, if you find 3, there is no corresponding element, so this is not a onto function. This particular function is not a bijection because if you find b 2, it has related to 2 elements, so this is not a on function. Okay, and if you find this particular element also, this is not a bijection because this is not either not on 1 and not on 2, not on 1, okay, and not on 2 also. So this is the bijection function all about. I think you are clear with the bijection function. Okay, let's discuss some examples of the bijection function. So if f is R2 are given by fx is equal to x plus root x square. Okay, fx is equal to x plus root x square. Then whether this particular function is bijection or not. So if you just break this particular function, it will be equal to x plus mod x. Obviously, root x will equal to mod x, which will be equal to 2x, x greater than 0. So obviously, if x greater than 0, then this mod will open with a positive value, and if it's less than 0, this particular thing is going to be 0. Okay, so means I think you understand this part, how to break the mod part. Okay, so fx is equal to x plus root x square is defined from R to R, means real to real. Obviously, if you to find a particular function bijection or not, so for particular part we have to check one function. Okay, so one how do we check? Obviously, if x not equal to y, okay, then this imply fx not equal to fy, means this is the part where it, obviously we choose how do we choose the one function. Okay, so to choose the one function, obviously like let's say we choose a value, let's say which we are choosing x is equal to minus 7. Okay, we are choosing x is equal to minus 7. Then that particular part x plus x, then fx is going to be 0. Okay, and if we choose x is equal to minus 9, in that part also we are going to get fx is equal to 0 because whatever the value choose between less than 0, we are going to get the same value 0. So obviously for more than 2 point, actually the thing is related to the 0 only. This is not a one-on function. Why this is not a one-on function? Simple funda. If you choose two value of, let's say x not equal to y, choose x is equal to minus 1 and y is equal to minus 2. So both the cases we get the 0 only because for x less than 0 we are going to get the 0. So obviously we got 2 point where x not equal to y. This would imply fx not equal to y. But what we are getting? We are getting fx equal to y. That's why this is not a one-on function. So obviously this is not a one-one. Obviously you can also check for the onto also. Okay. So at this point of time, like a bijection function, one-on function, onto function, we discussed a lot of examples. We discussed. Obviously, you can solve the examples in our terms. Let's now discuss the inverse of a function. So if means obviously inverse is defined for the bijective function only. So let if a and b is a bijection. Okay, so this is a bijection function. Then a function b g. So obviously we are defining a function g. So like let's say f is defined from a to b. Then there is something called inverse function which is represented by f inverse, and that f inverse which actually defined from b to a. Means everything changed. Whatever you define from there to there, you have to change the order. Okay. Obviously, it means that then a function g b from b to a, obviously this order has been changed, which associate each element of b to a unique element of a. Obviously, there we associated with element of a to the element of b, but now we will associate each element of b to element of a. This is what the inverse function is. So if x is equal to y is called the inverse of uh, if. Okay, so what this particular thing means that if fx is equal to y, this implied that gy is equal to x. Okay, so like this particular thing is represented by this way. If fx is equal to y, then x is equal to, take care, f inverse y. Okay, or obviously you can represent x is equal to gy also. Let's say we are representing f inverse by g, then we write x is equal to gy. So that is why gy is equal to x is represented. So obviously inverse function means that inverse of f is generally represented by f inverse. Okay, so somewhere you consider gx is equal to, let's say we're talking about out of context, we're talking about gx is equal to y, some other function gx. So x is equal to g inverse y. Obviously not the g that is represented here, some out of context g. Okay, so this is what the inverse functions means in our means for meaning. So obviously this is A set and this is B. So it is represented from A is going to 3, B is going to 1, C is going to 2. But to find F inverse, the same order will change. So 1 will be going to B, 1 is going to B, 2 is going to C, and 2 is going to C, and 3 is going to A, because this particular order will change. Now this is the B and this is A. This is what the F inverse is. So there are some properties of inverse functions. What are the properties of inverse functions? So like you should go and solve the questions from the RD Sharma. So I think RD Sharma, this notes I have taken from the RD Sharma. So obviously for maths part, RD Sharma is the best thing, and just solve the questions from the RD Sharma. And the function chapter is there. Just I will advise you to go and solve the questions from the function chapter. Okay. So what are the properties of the function? The inverse of a bijection is unique. So whatever the function you are talking about, if inverse of a bijection function, okay, inverse of bijection function is going to be unique function. It's not like that two or same, two or more kind of same function will be there. The inverse of bijection is also bijection. So like let's say fx is equal to y is a bijection function, then f inverse x, f inverse y is equal to x. This is also bijection, this is also bijection. Okay. So method of finding the inverse. How do you find the inverse? Simple is that put fx is equal to y. Obviously x belong to a and y belong to b, and then solve the particular thing in terms of y. So what do you mean by that? Let's say we have a definition of function here, which is represented by fx is equal to 3x minus 5. So you have to change this particular part to find the inverse of fx. So fx is equal to y you have to do. So we have to do fx is equal to y. It means that 3x minus 5 is equal to y. Okay. So we have to circulate this term and change this term in terms of x is equal to f inverse y. You know that this particular thing is there. So just change this particular thing to find x is equal to something, and that something will be your f inverse. So basically you take 5 here and divide it by 3. So we change here y plus 5 by 3. So basically I told you whatever x is equal to something you get, this is the f inverse. This something is the f inverse. So this something is called the f inverse. So obviously f inverse y is equal to y plus 5 by 3. Okay. So like this is the inverse of the function. So you can may ask that, obviously like some of the times we change the parameters. Obviously you change the parameters means that if you just change y in terms of x, you can also talk about the thing. Obviously change your x, you also change your x. So this not about the parameter. You also f inverse t, you also can see t plus 5 by 3. F inverse s, you can also see s plus 5 by 3. But this thing is not important. Important, this is the form of the inverse function of this particular function. Okay. So sometime it will also benefit some inverse function will not exist. Some inverse function will be something like that will be there. But obviously you have to see that, because a function or the inverse will only exist if the particular function is bijection. Okay. So we in the inverse itself we talked about a bijection function. So sometimes it may happen that particular function will not exist. Okay. Let's now discuss about some more examples, and I think this example is also not the difficult one. So what this example is telling about, it is saying that let f is equal to 4 to infinity, 4 to infinity. This means defined as from 4 to infinity, and the range is also from 4 to infinity, and fx is defined as 5 to the power x, x minus 4. Okay. Then what is the f inverse x? Okay. So what do you know f inverse x? Obviously, I told you put y and solve in terms of y. So they take both side log, then it will be x square minus 4x is equal to log y base 5. Okay. I think you know how to do the log. Then you need to solve this particular thing in terms of y. Obviously, x square minus 4x minus log 5y. So you need to solve this particular quadratic equation in terms of x, and if you solve the particular x, you will get the value. So like obviously quadratic equation you are aware of. If something like ax square plus bx plus c is equal to 0 means you to solve the particular solution is plus minus b uh, minus under root. Obviously b minus plus minus under root b square minus 4ac by 2a. Okay, so you need to do this particular thing, and you do this particular thing to solve this part, and actually what do you get? You get f inverse y is equal to 2 plus 4 log y. So this is the inverse of particular function. So like the whatever the domain of the function was here, and whatever the range was, if you change the f inverse, this particular thing will become the domain, and this particular thing will become the range. Okay, it's not like both are going to same only. Here it is same, some most of the cases it will same, but it can also change. Okay. The most important part is that the solve, put the whatever the y is, obviously uh, fx is equal to y, you have to solve this particular part in terms of x, and whatever you get that particular part, that will be the inverse. Okay. So also talked about this particular thing. So let's now discuss about some more examples of equations. So it is given that from the semi paper also. Let R denote the set of real number from, and let A is equal to x belong to R, x not equal to 3. So A means A is all this element of R, obviously minus 3. So you have that particular A here. Okay. So the A is x, means of all the element of real number, obviously excluding the R. So it's like how we write it. Obviously, you can write it some way. So for x belong to A, fx is defined as, as 2x plus 1 by x minus 3. Then obviously the thing is, it is asking about the f inverse x, and obviously what is the means obviously the function is defined from A to B. Then f inverse will be defined from B to A. Okay, so how do you find f inverse x? Obviously, to find the f inverse x, I told you just put it is equal to y, and what you get, 2x plus 1 is equal to xy minus 3y. Then what you need to do, solve this particular part in terms of x. So 2x minus xy is equal to minus 3y minus 1. Obviously, just multiply by both the side by minus 1. You will get 3y plus 1 is equal to 3y plus 1 is equal to xy minus 2x. Take x common here. Okay. Then what you get? 3y plus 1 divided by, if you take x common, it will be y minus 2 is equal to x. So this particular thing I told you, if you solve it, x is equal to something will come, and this something equal to f inverse x. So this is f inverse x. But the thing is that here, the if you find f inverse x, this particular thing is not going to take the value 2. If you take the value 2, that is going to be take the infinity. So this thing is not defined for y is equal to or x is equal to 2. So obviously, which of the following thing is correct? This is also correct. This is also sorry. This thing is the correct. But the thing is that this should not be equal to x is equal to 2. So this particular option is correct. So you have to find it this way. Okay. So the simple question is find the inverse and also find for which x it will be defined. Okay. So this was all about the function. I think you can also solve some more questions about the function in the uh, paper. Obviously, something called domain and range is left, but I will just cover that part later. Okay, domain and range. That's all for this video, including about the function, and we'll discuss more about the functions. Obviously, I think everything I've discussed, you can solve all the questions, but something related to domain and ranges need to be discussed. That we can discuss later. Obviously, you can read from yourself if you want. So solve the particular RD Sharma book, that is has some good questions from the function.